day, what I have to do is that I have to again take the previous three values and try to complete it. So similarly, we will be doing continuously like this for the next 10 days, so something like this up till the next 10 days, that is up to the 20th day. So this is what is my problem statement. Now, first step that I really want to discuss about over here is basically the data pre-processing. Okay, how we have to keep our independent and dependent features. As I told you guys, if I just consider this is my x-axis, okay. Now, if I'm saying that my previous timestamp, I'm just going to consider three timestamps. So this will be my T1 timestamp, this will be my T2 timestamp, this will be my T3 timestamp. Now, I also have to create my independent. So X is my independent feature, and here you have Y is my dependent feature. So I also have to create my Y value over here, which is my output. Now, how I will be actually creating? Now, understand this. Suppose this is my data set. Initially, I have my Y independent consider three timestamps. So this will be my T1 timestamp, this will be my T2 timestamp, this will be my T3 timestamp. Now I also have to create my independent. So X is my independent feature, and here you have Y is my dependent feature. So I also have to create my Y value over here, which is my output. Now how I will be actually creating? Understand this. Suppose this is my data set. Initially, I have first 10 days value or 9 days value. Okay. How we have to divide this? Suppose let me consider 1110, 125, 133, as my first independent feature. So I have 110, 125, 133. Okay. So this is my first record. Okay. Now if I consider my output Y, this should be my fourth day output. Okay. So this is basically my first record. Remember guys, this is my first record. If I just select this and press a tab. Oops. Okay. So let me just select this whole and press shift tab. So this is my record. Okay, this is my first record, and my first record independent features are 1110, 125, 123. That basically means on my fourth day, this is my output. So this is how I'm going to prepare my output.
Well,
Now, I mean the first record of the data. Now in my second
iMac, and I don't have CocoaPods installed. So we're going to be able to go through that together. Now, alternatively, a couple of great guides to install CocoaPods can be found on the official CocoaPods site under Guide.
record, I will now start with 125, because understand I need to now predict 158, right? And for this I have to use this past 3 days data, right? So I have 125, 133, 146, and then finally my output will actually be 158, right? Similarly, what I'll do, I'll just go next step. Now it will become something like 133, 146, 158, and finally my output will actually be 170. So like this, we will continue making all the data. Okay. So similarly, if I just go like this and I go on doing this, so my last record, you understand that my last output is 210, right? So considering this, my 210 output will be looking like this. So suppose this is my 210. Okay. And if I see this is my value as 196, this is my value as 187, and this is my value as 172. So I have all these particular values, guys, and this is will be my last record. But still, I have to compute the 10th day. For the 10th day, my input for the data will be, right? For the data will be 187, 196, and 210, right? Now, this value I don't have it, right? So this is how we are going to do the data pre-processing. So how many number of days we have, and trust me guys, for every time series problem, we have to make, or we have to pre-process our data in such a way that we'll be able to create our X and Y value, that is our independent and dependent features, based on the number of timestamps that you have taken. So I have taken over 3 timestamps. I've told that based on previous 3 days, I have to actually calculate. Now similarly, once I get this value for the 10 day, that what I'm going to do, I'm going to take this 3 as my independent features, then I'm going to compute for the 11th day, and I'm going to do it similarly in that way. After doing data pre-processing, guys, I'm going to apply my LSTM model, a simple LSTM model, simple LSTM RNN model. Because understand, these all are sequences data, so RNA will pretty definitely help, right? So after calculating, after doing that, then I'll be predicting for the future 10 days, and finally we will be plotting this. So these are the steps that I'm going to show you in this particular video, what all we are doing, and we'll go one by one. Okay, so let's go ahead. Now first of all, this is the code. The code is actually given in the GitHub. Every information is over there. Now what we have to do is that, let me just expand this and make it a little bit zoomed in so that you'll be able to see it properly. Perfect. Now the first thing that I'm going to do is that I'm going to import some of the libraries, and remember guys, this I'm working currently in TensorFlow 2.0. If you're not working in TensorFlow 2.0, you can remove this TensorFlow, but the whole implementation is in Keras. Since TensorFlow greater than 2.0, the Keras is integrated within the TensorFlow, right? So let's go ahead and try to see this. So first of all, I'm going to import all the libraries that are required, like sequential, LSTM, dense, and splatter. I'm also going to import NumPy. Now let's go ahead with my data. So I have my time series data, which is same values that I've actually shown you over there. Okay, I'm going to choose the number of timestamps. Number of timestamps basically means that I told you, this is my timestamps. I told you based on the timestamps I have to pre-process my data, right? So here again I have taken 3, and you can select your own value. You can select 4, 5, 6, any number of values that you want. Okay, then you can see that I can select, I have to with my data. So I have my time series data, which is same values that I've actually shown you over there. Okay, I'm going to choose the number of timestamps. Number of timestamps basically means that I told you, this is my timestamps. I told you based on the timestamps I have to pre-process my data, right? So here again I have taken 3, and you can select your own value. You can select 4, 5, 6, any number of values that you want. Okay, then you can see that I'm preparing my independent and dependent features from this particular function. Now this function takes our time series data, all the time series data, and my number of features, that is. Okay, now when this is done, we'll go inside this particular function. So this is my function. So here I have my time series data, I have my number of features. So you can see number of features is. So here I'm going to initialize x and y, which will be in the form of list. Then I'm saying for I in range, length of time series data. So I'm just going to see, I'm going to iterate through all the elements in the time series data. And then I'm going to say that for the first time, based on the number of features, just try to find out the end point, end value. Okay. Now suppose in this particular case, when I'm iterating through this, right? So my end value will be something like this, right? So what I'll do, I will be taking all this particular value in x-axis, and this particular value I'll be taking in my y. So that is what I'm doing over here. So you can see that I'm checking whether end value is greater than length of time series data minus. If it is greater, that basically means it has reached the end of this list. I'll come out by the break state. Otherwise, what I'll do, I told you that from times data from I is equal to end of x. So that basically means from this particular value till here, I'll be taking that and I'll be storing it in my sequence x value. Similarly, from time series only for the end underscore ix. End underscore ix basically means that for the first iteration, this will be 0 plus number of features is nothing but 3, right? So third index you can say. So which is the third index? 0, 1, 2, 3, right? So this is the index. This will get stored in the y-axis for the first time. Okay. So that is once done. And similarly, this will be happening for all the data inside this time series. And finally, you'll be able to see that I'm appending that in my x and y value. And then I'm returning this array of x and y. Just try to execute by your own, guys. You will definitely be able to understand. This is pretty much simple because if you understood this logic, the code is pretty much simple. So I have explained you in this particular manner how we are actually doing the data print. Now I'll execute this quickly. So after executing, let me print x and y. So this is my x values. Okay, this is my y value. This basically means that for this x, this is my output y. For this value, this record, this is my output. For this record, this is my output. For this record, this is my output. Similarly, I'm doing all this. Now, let us see that what is the x dot shape. X dot shape is nothing but 6, 3. Obviously, it should be 6, 3 because I have 3 features and 6 records. 6 records has been created. Now, this is a pretty important step, guys. Understand from this two, when I see x dot shape, right? This is nothing but the number of records. This is basically the number of timestamps. So timestamps is pretty much important over here. Okay, and always remember whenever you are implementing LSTM, you always have to reshape your data into a 3 dimension. How? What all 3 dimensions are required? One is the number of records. The second one is with the shape of this particular, how many number of timestamps are there, and one should be something like n underscore features. Okay, so n underscore features, don't get confused by this timestamp and this feature set. Okay, timestamps I'm considering just like a features over here, but this feature is just something different where we are just trying to convert this shape into a 3-dimensional shape. If you want to convert this, you just have to use 1 over here so that it becomes 6 cross 3 cross 1. Okay, the same number of elements is just being converted from a 2-dimensional into a 3-dimensional. Okay, so that is what this step is done, and this is pretty much important. You can see over here, reshape from sample underscore timestamps into sample underscore timestamps underscore feature. Okay, so just like this kind of example is given over here. But just understand this reshape is pretty much important. Okay, we are just trying to convert this 2-dimension to a 3-dimension so that we will be able to give this as an input to our LST. Okay, and this is pretty much important. Now, the next step after we do this, if I execute this one, then you will be able to see that.
Messy writing can cost you a lot. Grammarly Business focuses on.
Okay, let me just see the X shape now. See that X shape is 6, 3, 1. Pretty much simple. Now let's go ahead and try to define or build the LSTM model. This is pretty much simple, guys. I hope everybody knows this. Initially, I'm creating a sequential layer, then I'm adding an LSTM layer. Activation is ReLU because again, I'll tell you, ReLU works pretty much well with LSTM. The return sequence is equal to true. Here is the most important thing. Okay, guys, this is pretty much important. In the input shape, we have to give n underscore steps and n underscore feature. If I try to see what is the n underscore steps, this is basically the 3 value based on the number of time steps. Or I can also say this as number of time steps And this is basically what we have actually done with respect to the three-dimensional conversion, right? The last feature, which we require, we have to give that as an input shape into our LSTM. Okay. So guys, in the next layer, again, I'm adding an LSTM layer of 50. Neurons, and here I'm applying an activation function as ReLU, and finally this is my out. So guys, in the next layer, again, I'm adding an LS layer of 50 hidden neurons, and here I'm applying an activation function as ReLU, and finally this is my output node, or the neural network node, basically, where I'm keeping the value as 1, so that we'll just need one output. Then we are doing model.compile, optimizer is equal to Adam, and loss is equal to mean squared error. Finally, let us do it for 100 epochs and try to see. Just let me increase it to 300 epochs, and let me quickly fit the model over here. So we will be fitting the model. Let's see, we'll face any errors or not, or it will just get executed quickly. Yes, it has got executed quickly. If you really want to see verbose is equal to 1, you'll be able to see all the epochs, that how it is basically taking place, and here you can see all the epochs. So quickly, and since the data set is very, very small, guys, and the execution time will be. Variables. Okay, so this, once my fit is done, okay, now this is the most important step. Okay guys, so the next step is that I'm going to predict for the next 10 days after I have actually fitted my model. Now this step is pretty much important. What I'm going to do, as I've shown you my data set already, for the 10-day computation, I will be taking the previous 3 days data. Okay, so previous 3 days data I'll be taking over here, and then I will be computing the 10-day output. After getting the 10-day output, I will again append this to my input so that I can compute my 11th day. So for that, I have written this particular logic. This will be happening for 10 days. Okay, there are two statements, if and else. First loop, it will go to the else block, because we already have the 3 days input, right? In this particular block, as soon as it goes, we are basically adding. Suppose we are, once the output is got, we will be appending in this particular list, and then we'll be taking this last 3 values to calculate the next value. So similarly, we'll be going on. I would suggest just go through this logic. I have written this particular logic to get the output. Okay, so you will be also able to see that I'm printing the values also over here, like what is the first day input, what is the second day output, what is the first day output, and all like this, right? So I'm printing this. I would suggest, guys, this is a very interesting logic that I have written. Just go through this and you'll be able to understand. But understand the logic is something like this. Okay, suppose this is my 9th day output, right? I will append this over here to my input, and it will start from 186 like this. And then I'll compute the next day output. Then again, I'll be taking this particular value. This will become my input, and again, I'll compute the output. Then again, I'll be taking this 3 as my input. So that is what this if and else logic will actually do. Okay, so let me just execute and show it to you. So here you'll be seeing that, okay, the first day input is 196, 210, 222, right? So this is my first day input. If you really want to see the first day input, then what I'm going to do after this is that, remember, I have given this as my first day, right? 187, 196, 210. If I go and see in the else block, I have printed y hat of 0. So this is basically my output, first day output. Now what I've done, I have appended this over here inside my list. And you can see that I skipped this 187, right? So it is starting from 196, 210, 222. Then for this, I will be getting this particular output. Then what I'm doing, again, I'm appending this to this particular list, and it is starting from 210 till this particular value. Again, I'm getting the output as 247. Again, in the next day, my input will be looking something like this. You can see that it is clearly given in front of you what are the output I'm getting for a specific day, and for the next day input that is actually added at the last. And remember, always the size of this will be 3 timestamp. Okay, 3 timestamp, and again we'll be getting one output. Again, I'm adding this 271 over here inside this particular list. Again, I'm taking it from 247. So like this, it will continue. This is all my final output for the next 10 days. Okay, this particular list, and this particular list is actually stored in list underscore output. Now what I'm going to do, this is my time series data, this is the length. I'm going to create some date for this. Okay, so first I'll create the date of 9 days, right? So this data that we had, right, the whole data that if I show you, this whole data was for 9 days, right? So I'm just going to create the date for those data, just like day 1, day 2, day 3. So here I've just written np.arrange 1, 10. Then I've written the prediction data is from 10th to 28th day, right? So 2 days pattern I've written, and I've just plotted day comma new with time series data. This was my data set that I had, and day underscore pred, which is basically my predicted data set from 10 to 20, and I'm plotting it with my list output. Now once I execute this, you'll be seeing this amazing results, right? Now here you can see that this is my data that I had, and this is the data that is being forecasted by the LSTM, right? Isn't it amazing? I know you'll be thinking that, Krish, the data will always not be like this. Yes, the data is not always like this, and you cannot just, here you can also see that, right? After some point it's coming down, it is going up, it is coming down and going down, right? So similarly, this is just done some kind of prediction, which is pretty much similar to this kind of line, right? So this is how we have done this particular visual analysis, about the visual analysis of the time forecasting. And this is how we can actually easily develop an LSTM model for univariate time forecast, time series forecast. Now, probably this is pretty much good, because now we can take the time series forecasting of stock prices, or Google stock prices, or Microsoft stock prices, and we can actually implement LSTM RNN and see that how it will be doing the prediction. So I hope you like this particular video, friends. In the next video, I will be coming up with more different kind of multivariate time series forecasting also. So many of you had also requested to come up with multivariate time series forecasting. That also I'll be explaining it. All this particular code will be given in the GitHub that is provided in the description box. I hope you like this particular video. Please do subscribe the channel if you have not already subscribed. I'll see you all in the next video. For every time series problem, we have to pre-process our data in such a way that we'll be able to create our X and Y value, that is our independent and dependent features, based again, this is a stacked LSTM model, one LSTM after the other, right? And finally, I've added one more. After that, you can see that I've added one final.
那在这里呢，我来给大家讲一下正则与可行解空间的它的关系是什么。我们可以回想一下，当我们去优化一个目标函数。
Hello all, my name is Krishna and welcome to my YouTube channel. So guys, this video is about stock market prediction and forecasting. We will be considering one stock, one company's stock price, and then we'll try to see that whether we are able to do the prediction and the forecasting by using the stacked LSTM. The one thing I really want to request you all guys is that please don't use this model for your personal investment. Just don't think that this model will give you any kind of profit, because understand stock market. Yeah, I just tried it to do it by using stacked LSTM itself. I just wanted to show you how we can actually do it. Just don't use this in your real world life, so that you put some investment and then after that you lose some of the investment itself. So please don't do that. I request you all. Now let's go ahead and try to see how we are going to do this. Okay, we are going to use stacked LSTM, long short-term memory, and probably this video will be more than 20 minutes, guys, because I need to explain you step by step. In this, I have actually taken Keras and TensorFlow greater than 2.0. Okay, so I've used this libraries. I've used LSTM, long short-term memory, stacked LSTM. I'll tell you how we can actually create the stacked LSTM, and we'll actually understand. Now the first step is basically the data collection part. Probably for this, we need to have some kind of data, right? And I'll just show you all the steps that we will be performed. First of all, we'll collect the stock data. In this particular example, I'm taking the Apple data set, Apple company stock prices, from 2015 till today, till 25th. I'll try to take that particular data. Then we'll pre-process the data. That will divide that particular data into train test. Before doing that, we need to do a lot of pre-processing, which I will be explaining. Then we'll create a stacked LSTM model. We'll train it. Then we'll predict the test data and plot the output. Finally, we'll predict the future 30 days. Means that this means future 1 month from today's May month. We'll try to predict that, and I'll try to show you that the output and we'll plot it. So let's go ahead with the first step. So here is your data collection strategy, guys. Here I'm going to use a wonderful library which is called as pandas_data reader. If you really want to see what in this particular documentation you can go regarding pandas data reader, it provides a lot of libraries where you can actually access this kind of data. So currently I've selected Tingo. Okay, in Tingo you can see over here it's pretty much simple. Just go into the Tingo site. Okay, just log in inside this or sign up, and then you click on the API part. In API you'll be able to find the key. If you go down in this particular section, in the authentication section, you'll be able to find your own API key. I will not share it with you guys because I'm going to use that for my personal purpose. And trust me, for 50, you can actually request 15 times in a day using this particular API. So it is a wonderful way that you can actually collect any amount of data that you like. Now, I'm going to import pandas data reader as PDR. Then, guys, and this pandas_data reader will be already present in your Anaconda environment. Then you have a method which is called as get_data_tingo. Just give the stock price, this particular name, that is AAPL. For Google, you can write GOG, and the another parameter is basically your API_key. Okay, so just give this key name. This key name I've already defined over here, but I'll not show it to you guys. So you can execute this particular line and get your value, all the whole data frame inside your DF variable. Then I will be saving this particular file in .csv. As I told you that we just have 50 requests that you can go ahead and hit it. But after this, you can again re-upload your data set from this apple.csv file which you have actually stored. saved, right? So below this particular cell, what I'm going to do is that I'm just going to write df.head and show you how the see the tail of this particular df.head, you will be able to see that I'm having this sorry, dot tail. If I make it dot tail, then I will basically be having from till 22nd May. Okay, so I have the data till 22nd. $20.20 for the Apple stock price. Now what I'm going to do is that quickly I'm going to take this close column. Okay, I'm going to take this close column, and for this particular price we'll be doing the stock prediction. You can also be you can also be able to do for other by using the same strategy and method. Okay, so let's go ahead and try to quickly show you how we can actually do this. Till then I'll Okay, so let's and try to quickly show you how we can actually do this. Till then, I'll just delete this cell because we don't require it. Okay, now what I'm going to do, that first of all, I just want to pick up this close column, right? So for this, I'm writing df.reset index. If I do reset index, that basically means all this particular value will be going inside this. And then I'm just going to take close column. Okay, so by this I will be able to get all my close values in df1. So if I can see the shape, it is having 1, 2, 5, 8. Okay, so if you want to really see the df, I'm having these values like this. You can see that it is increasing as we go ahead till 1, 2, 5, 7, right? If you really want to plot this particular data frame also, you can use matplotlib.pyplot as plt and just use plt.plot. df1. So here you can see that this is how your plotted stock price looks like, you know, from 2015 till 2020, right? So this is how your stock price is having the movement, has both up and down movement. So let's see how we can actually solve this particular problem. Now, one thing that you need to note is, guys, LSTM are very much sensitive to the scale of the data. Now, in this particular data, this value is in some kind of scale. So we should always try to transform this particular value. In this particular example, we are going to take min-max scalar, where we'll be transforming our values between 0 to 1. So for this, I'm going to import NumPy. I'm going to say from sklearn.reprocessing, import min-max scalar. In the min-max scalar, I'm going to take a feature range between 0, 1. Okay, so this is the value that you need to give when you want to scale down between 0, 1. Suppose you want to scale down between -1, 1, you can give that value. After that, I'm saying that scalar dot underscore transform np.array df1 dot reshape -1, 1. You have to do this particular step, guys, so that you'll be able to provide this particular input to fit underscore transform. Now, let me quickly, first of all, show you how. Your df1 looks like, so your df1 has values like this, 132, 131, right, all these values. Now after executing this step, you will be able to see your df1 will be now converted into an array, and it is now having values between to 1. Okay, so it has got transformed between 0 to 1. Suppose if I try to print this value, let's see, you will be able to see all these particular values that are there. And remember, this is between 0 to 1, all these values, so that you can actually see over here. Now, the most important step, right? Over here, I told you that we have done this particular step. I'm just going to write done. Okay, now we need to pre-process the data. Before that, let's go and do the train test. Now, one important thing, whenever you're dealing with time series data, guys, understand. Suppose for the first day the stock price was $120, then it came to 130, then it came to 125, 140. I'm just taking an example, guys. Okay, so 150, 160. Suppose this many information I have right now, right? Now, first step, what you always have to do during the train test split is that there are various ways of doing train test split, right? One is cross validation. Okay, one is directly by using some random seed. Okay, but these all methods, if I talk about these all methods will work very well when you have a linear regression or a classification problem. In case of time series data, guys, in case of time series data, we should try to divide the data set in a different way. So how do we divide? First of all, what we do is that in our training data, what we do, %70 of the initial data, and this should be ordered with respect to date. Okay, because understand, on day 1 this value was 120, on day 2 it was 130, day 3 it was 125. Now we can basically say that day 2 can be dependent on day 1, right? Similarly, day 3 can be dependent on day 2 and day 1. Day can be dependent on day 3, day 2, day 1, like that. So we should try to divide this data based on date. Suppose I say that my 70% of data is here till here. So this before all the data is basically my 70% of the data. I can actually take this into my training data set. Okay. I can take this all into my training data set. And for the test data set, I can actually fix this. Okay, so this will actually be my test data set. Now I'll tell you why we are doing like this thing, because after doing this division, okay, we will try to do the data tree processing. But always understand that whenever you have any kind of sequence of data or a time series data, the next data is always dependent on your previous data. Okay, so you should always try to do this division in this particular way. So let's go and do this particular step. So over here, you can see that I have taken an example. I'm telling that the splitting the data set into train and test split. So first, I'll just take my train size. What should be exactly my train size? In this particular case, I'm saying that 65% of the total length of my data frame should be the training size. Okay. Similarly, over here, I say that my test site should be the length of the data frame. Minus the train size. So definitely if train size is 65, then 35% will be actually my test size. Okay. Now considering that, I'm going to use this particular length and I'm going to create my train underscore data and test underscore data. How? In df1, I'll say from 0 colon training size. That is whatever training size I'm getting over here. If you want to see the training size once I execute it, okay, I'll just execute it. Now let me just show you. What will be the training size? This is my training size, this is my test size, right? So these two values that you can see over here, 817 is my training size and 441 is my test size. So 0 to 817, I will get all those data from this data frame, that index, this is 0th index, first index, second index, like that. Till 817th index, I'll get inside all my training underscore data. And then remaining all the data after that, after 817th index, it will get stored in the test data. So once I show you over here, I've already executed this. If I show you my the length of training data, so which is my train data over here, you can see that it is 817. And similarly, if I show you the length of test underscore data, it is 441. Now if you want to see the training data, just go and type training data and you can actually see all these particular values.
How's it going, everyone? Welcome back to another video.
Right? Similarly, test data will be the remaining part. You can actually print those values. Now, the most important step. We have done the train test split. Now let me just go back to my notepad. Now understand this is my data set. Okay, I'm just going to press enter so that we have some space. So I'm going to copy this particular data set in my training data set. Okay, so this is my training data set, and similarly this is actually my test data set, right? This is actually my test data set. So this is my test data set. Now we need to do a wonderful data pre-processing. Or what is that data pre-processing that we have to do? Okay, so let me just show you. Now understand, guys, this data that we have, suppose this for day 1, day 2, day 3, day 4, day 5, day 6. Okay, so what I can do is that I will be now considering one time steps. Like suppose if I want to compute the next day output, okay, how many previous day we have to consider. Okay, how many previous day we need to be dependent on. Suppose over here I take an example of 3. If my time steps is 3, then I will basically be having 3 features, F1, F2, F3. The first feature, the first feature over here will be having the 100 value, sorry, 120 value. Remember over here 120 is over here itself, so I'm taking it as 120. The second value will basically be 130, 130, and the third value will actually be, or the feature 3 will be 125. Now when I have this, then my output should actually be 140. Now what we are doing in this data pre-processing, guys, we are just converting this into independent and dependent feature based on this timestamps. This basically indicates to calculate this, I need to consider the previous 3 days input, whatever input over here is there, right? Previous 3 days. Similarly, for the next, sorry, this should be 140. Okay. For the next record, what will happen? I'll just shift one position to the right. Now my new input will be 130, 125, and it should be 140, and then my output actually should be 130. So we will be actually doing like this. We'll convert this whole data set and convert this into our training. This F1, F2, F3 will be my X string. So I'm just going to write it down over here. So this will be actually my X string, and this will be my Y string. Pretty much simple, right? These are my two data sets. You can clearly see that independent features, dependent features. Now similarly, this is my independent and dependent feature. Now considering this data, I will try to use it in my LSTM model to train it. Then for the test data also I have to do this in this way itself. In this similar way, I need to make this particular split, right? Suppose I have some more elements like 160, 170. Okay, I've just taken some example, guys, so please bear with me in this. So okay, here also I have to do the same processing, that is F1. F3, right? And here, this will be my output. Remember, whatever out, this is basically my y underscore test. Okay, and this actually is my y underscore. This is my y underscore train, right? So I have all this particular information clearly given to you. Okay, now similarly what I'm going to do, I'm going to write (160) over here. You will be able to see it. I'll be writing 160. First, my data pre-processing will have 160 over here, then 190, then 154, and then my output will be 160, right? Similarly, you can see that I've taken the first four elements. Now in the next element again, what will happen? If I see over here, it will just go over here, it will take the next three elements, 190, 154, and 160. The next output for this is, you can see 170. So this will basically be my white test. Then what I'll do is that after I train my LSTM model with this training data set, I will take this test data set and predict it, and then try to compare with my y underscore test. And then we will be seeing that how good the accuracy is coming, how good the forecasting is actually coming. So we have understood this. The data pre-processing is pretty much simple, guys. I have created a method which is called as create data set. Here we actually take the data set, then the timestamp. In the timestamp, by default, whatever values I something like 100, it will be taking 100 timestamp like this. Here in this case, it is 3 timestamp, right? So here it will be taking 100 timestamp. And remember, the more better you have a timestamp value, this is again a hyperparameter tuning technique which we will be selecting those timestamp values. So inside this particular method, that is create data set, what we are doing, first of all, we give out training data. Similarly, how we divided the training and test data on the top, right? Like how we explained over here. Now for this trained data, I am saying that, take the timestamp value as 100, okay? Make your data set as X and Y in this particular manner. This is the 3 lines code, guys. Understand, in the first iteration, you'll be seeing that in the 0th iteration, 0, 1, 2, 3 elements will be going as your first record, and your third element will be actually, fourth element will actually be put up in the X if your timestamp is 3. If your timestamp is 100, like this, it will be happening for 99 elements, and then this will be in your X train, first record. And in your Y train, you will be having your 100 elements, right? Similarly, in the next record, again, you will be starting from first element till 100 element, and 101 element will be going in your Y axis. So if you consider this particular example, I can consider like this. Let's see. So in the first F1, it will be like, how many features will be there? Somewhere around F100, right? So suppose it goes over here like 130, right? Like this, it will be going all the elements, and 138th element will be actually my 131. Suppose I'm taking, then my next element output, suppose it is 140, okay? Then suppose this was my second element, like 136, okay? Then what I can do is, then in next record, it will start from 136, and then I will continuously be having this output, okay? And the last element over here now will be 140. Okay, and similarly, this particular element will be the next element, whatever we need to predict, or we have already, we have that. Data. So we'll try to do in that particular way. And these are the 3 lines of code which will actually help us to do it. Okay. Inside this, you can just check it out, guys. It's a very simple for loop over here that I've written. I'm traversing through all the data sets. I'm making sure that based on this particular timestamp, I'm putting that much data into my X and that much data into my Y. Only single data into my Y, and I'm returning those values. Just check this, you'll be able to understand. So I'm just going to execute this. I've got executed this. My X.
Today we're going to be going through the NumPy library, which is considered to be kind of the fundamental package for all scientific computing in Python. So it's a super, super important library. It's kind of the base for a lot of the other like major data science libraries in Python. So like Pandas that I've done a video on before, it builds pretty much like entirely off of the NumPy library. So it's super important, and kind of because it's important is because it's this like base. The way we're going to do this video is I'm going to start off with kind of a background information on how NumPy works, and I think really having that intuition is helpful. Smash that subscribe. And so the common, so we have in 6. That's right through each store you to and we can also do those same exact things in NumPy. I guess yeah, one, etc. But pretty when it comes to the back end of many different applications. So Pandas, which I've done a video on before, is NumPy to store the direct. So the NumPy library will to initialize. Other useful things to know about this is how to. So this tells me that it's one-dimensional for A, and if I did B dot and M, it would be 2. Shape is another important function. 3 rows and 3 columns, so it should print out 2 by 3, as it does. Okay, other things. We want to know how much memory our NumPy arrays take up. So we can, oh sorry, type we want it to store as, so maybe size in a sec. So this 4 bytes down here. I guess a.size, another way to do that is I think just number of bytes. As you see, that's the same. 8-byte type. So if I do b.item size, as you see, it's like this, so that how we access dimensional array. Okay, so this is a 2 by 7 array. If I print, what do we want to? So that would be in the second row, but because we start Python indexing at 0, be the first row, and then the 0, 1, 2, 3, 4, 5, 5th column. So yeah, that gives us the 13 as you see down here. And one thing that's kind of cool is Also use the negative notation similar to so I could also I can just do a single column and that will get me everything in the row. Nice. What if we want a 10? And some more like tricky stuff. So end index, and then finally the 4 and 6, 2. I actually screwed that up. It should be 1. So I start at the 2, then I want to end here at the 6, which is the, it's exclusive, so that would be, I want to actually go to the 6 element. And I want to step by 2 because I wanted 2, 4, 6, so I did 1. And that gives me 2, 4, 6. And I can also use the negative here and do like -2. Ah, what happened there? Oh shoot, that was going backwards. I didn't want to change it there. Oh. Change the 6 to be -2. Ah, okay, it's exclusive, so when this die. -1. A little bit more of a fancy way to do that. Okay, so that's how you access elements. And next, let's talk a little bit about reorganizing arrays. So kind of I would say the key method within reorganizing arrays. So if I have the array, I'm going to call it before. And let's say that that is equal to this value right here. So we have before, I'll print before out. Looks like that. So let's say we wanted to, instead of this shape that it currently has, which is a 2 by 4. Let's say we wanted to make it a, I don't know, a 8 by 1 or something, or maybe a 4 by 2, or all sorts of different things we can do. I'll start with 8 by 1. So we have before, and if we wanted to make it something else, we can do after equals before dot reshape, and then we pass in the new size we want it to have. So if we wanted it to be an 8 by 1, we pass it in like that, and then print out after. as you can see, it's an 8 by 1 now. I could also say I wanted it to be a 4 by 2. So now you got that. You could even pass it in as a 2 by 2 by 2. As long as it has the same amount of values, like it's fair game. So as you see, 2 by 2 by 2 still works with the reshape. Doesn't work is like if I wanted it to be 2 by 3. The values don't fit in. So when you get errors using the reshape, it's usually because there's a mismatch between the shape you're trying to resize it to versus the original shape. Moving onwards, let's look at vertical. Stacks. So vertically stacking vectors or matrices, and you know, dimensions are important in vertical stack as well. So vertical stacking matrices. Let's say we had these two arrays. If I wanted to stack, 1, 2, 3, 4 on top of 5, 6, 7, 8, I can do np.vstack. I can pass in v1, v2. And as you see now, they're part of the same matrix, and 1, 2, 3, 4 is on top of 5, 6, 7, 8. I'll use a submit H2 to be on the back of H1. I can just do an mp.hstack, horizontal stack, and that will be H1. H2. And that did not work. Because I did not surround. This in parentheses, either parentheses or brackets. I think they both work. Yeah, there you go. So now we've horizontally stacked the zeros on top of the, or to the right of the ones. All right, let's get into some miscellaneous things. So first off, imagine you have, some sort of text file with all sorts of data, and for whatever reason you choose, you don't want to use pandas, but you want to load all that data from that file into a NumPy array, GitHub page. Pass in the name of the file, which is data. Type in the int30. What happened there? Next, indexing. So this indexing is I could do np, or let's say that this is a. I could do a of 0. As you see, that could all these greater than 50. So yeah, now the 6th spot is the first that you just columns are then especially like this, where you get the 0, 3, yeah.
It's getting started.
Into my x and that much data into my y. Only single data into my y, and I'm returning those back. Just check. Will actually help us to do it.
this video, I'll kind of help you demystify the myth that you have regarding the reshape function. Hope you all like it. And start with a simple example. Firstly, I'll import the necessary modules which are required. The whole objective of this exercise is to create a linear regression model for x and y, where x ranges from 0 to 99 and y. Ranges from 0 to 99. Let's see how reshape can kind of help us when we get an error. Okay, so I defined two numpy arrays ranging from 0 to 99. Let's see if it's correct. So yes, x ranges from 0 to 99. Similarly, y, when I fit a linear regression model, n would be y equal to 10x, where would be 1 in our case. Okay. Now I create an instance of the linear regression. And now when I call the fit function, wherein I pass in the parameters x and y, this is the error that I get. So x in fit function is expecting the x value to be a 2D array, but I am giving it a 1D array. Okay, let's check if this is correct or not. So I'll check for the dimensions. In X, and I see it's a one-dimensional array. Similar. Y is also one-dimensional array. When I look at the shape, it's 100, comma. Nothing. Similarly for Y, it's 100, comma nothing. So ideally a two-dimensional array should be 100, comma 1, wherein you have 100 rows and 1 column. But in this case, since the dimension is 1, you don't have the second dimension. So it's just 100 elements and no row column concept so far. Okay. Now we have reshape -1, 1 to our rescue. What this would do for us is, it will say, hey listen, whatever shape you're giving me, I'll create an instance of that array in such a way that I'll add a new dimension. So in our case, since we have 100 rows or 100 elements, I'll first create 100 rows for you and add one more axis, which is 1 in terms of the column that is there. Okay, so the whole bare minimum idea for reshape is, wherever you're giving a -1, those many elements remain as is, and a new dimension is added wherein you specify the 1. Now if I do x dot shape, now it's 100, comma 1, that is 100. Rows and 1 column array which is generated. And now check the dimension using ndim. There are two dimensions for x. Now if I try fitting the linear regression model on x and y, it successfully fits based on the data that I've provided. And just to check if I'm able to create the line, and yes, I'm successfully able to model on x and y. It successfully fits based on the data that I've provided. And just to if I'm able. This was a simple example that demonstrates how reshape works, wherein you have 100 elements. You want to convert that one-dimensional array into two-dimensional array. Wherever you say a -1, those many elements of that one-dimensional array are as it is, and where you specify a 1, a new dimension is added. You have a row column like structure. It's from 1D to 2D. Similarly, you can have a 2.
will actually help us to do it. Okay, inside.
Hi everyone, and welcome back to the 8th video in the Python 3.0, which uses in like including and then app. So what you do is you can do range. So it's range function. In the next tutorial, we're going to be
What's going on, everybody? Welcome to part 25 of the intermediate Python. More args and your args argument. So again, like a dictionary. Can have as many things in the dictionary as you want. Okay, so args and quargs kind of function like that. These are keyword arguments. That's the key W or KWRs, keyword arguments. And these are just arguments, and it can be a list of any arguments. Out of webs, take like a here, and we can say blog posts, and let's say for now you just started your blog, you just have blog 1. I know we wrote blog 2 and 3 already, but right now we just want to host blog number 1. Maybe we want to go back and edit the cars and cat one. So we're save and run that, and what we get is just that one blog, I am so awesome. Now later on you decide, yep, I'm ready. Publish the other blogs. So blog 2, blog 3. Actually, there you go. And we need items. So it's like a dictionary. Kind of something. You can, a lot of times you're going to see function. I really don't know. So I'm just going to say for R in C head and print, and let's say or actually we don't need a print, so we're printing, I want to say, and I'll keep that print and graph operator requires. If you have any questions, comments, concerns, if you've got something cool you want to show us, leave it below. Otherwise, I'll see you in another tutorial.
And then I'll.
What's going on, everybody? Welcome to part 25 of the intermediate.
Welcome back, aliens. My name is David. Doing with those parameters are a different thing, okay? Here.